Today's question is about counting sub-islands, Leetcode 1905. The question is as follows. So you're given two grids. Both of these grids only contain ones and zeros. One represents land and zero represents water. A bunch of land connected together four directionally, which is horizontally or vertically, is considered to be an island. Anything outside is considered to be a water cell. So, an island in grid 2 is considered to be a sub-island if there is an island in grid 1 that is a superset of it. So let's see an example on the next slide. So we have two grids, grid 1 and grid 2. So as you can see, the top island highlighted in red on grid 2 is a sub-island of the top orange island in grid 1, as the island in grid 1 is a superset of the island in grid 2. The same can be said for the two islands at the bottom left in grid 2. Both of them are sub-islands of the island in the bottom left in grid 1. So in total there will be 3 sub-islands, and we return the answer 3. So let's restate the question. So essentially what we need to do is to find the islands in grid 2 that are subsets of islands in grid 1. So the first approach that one could think of is to first identify islands in grid 2 using depth first search and store the row and column numbers as a tuple in a set and call it ST1. For each island that we found in grid 2, we can check that if there is an island in grid 1 that is a superset of it. And we store the island from grid 1 discovered here in a set ST2. And then we also have a result counter, which is a number of sub-islands, and we add 1 to the result if ST1 is smaller than or equal to ST2, which would mean that ST1 is a subset of ST2. However, is this really a very optimal approach? Because we are performing DFS on both grids, as you can see through the code snippet here. Is that really required? Moreover, as you can see in one of the lines in the code, we need to reset the visited matrix for grid 1 every time we depth first search on it. Let's understand why we need to do that. So in this example, we are at the second DFS call at the grid 2 position 40. So when we start the DFS call, we will start the DFS call at the same XY coordinate in grid 1. And after that DFS is done, we will realize that it covers the entire island as highlighted in red on the bottom on the left of grid 1. So when we call our DFS again for grid 2 position 44, we will realize that DFS on grid 1 cannot continue as the island in grid 1 is already visited. In essence, if you look at visitor matrix in grid 1, the value at 44 would already be visited, so we cannot traverse to that. So because of this, we will be neglecting grid 2 at position 44 being a sub-island. Thus, we only return a much smaller number of sub-islands than what's the actually true number of sub-islands could be. So this is why we need to reset the visited matrix every time we perform DFS newly. Moreover, we need to work towards an optimized solution, as there is additional time complexity and space complexity from what we have done so far. For space-wise, we are storing islands in a set, which takes up more complexity, which takes up more space. And we also need more time as we are DFSing through 2 grids instead of 1. So how is it possible for us to perform DFS only once on 1 grid? So here's the solution. So we only consider an island from grid 2 to be a sub-island if the same squares it occupies when looked at in grid 1 are also land and not water. So we need to check that if for every square there is an island in grid 2, its grid 1 counterpart is also land. So here we have our variables for the code. So we have result, which is a result counter. We'll start at 0, and the visited matrix will be false for the rows and columns in the grid. So this is the main traversal loop. So for each row and each column in the grid, if it's not visited and if its value in grid 2 is 1, which means it's land, we start our DFS function on this row and column. And this DFS function will return boolean we will return a boolean saying true or false if it is a valid sub-island. And if it is true, we add 1 to our result. So let's see how our DFS can be modified to suit this methodology. So let's look at the DFS function. So initially, we look at I and j, and we look at the grid 1, at the square in grid 1. If the square is water, which means that for the land in grid 2, it is actually water in grid 1, which means it's not actually possible for this to be a sub-island. So we immediately return false here. And of course, to prevent infinitely going through all the rows and columns again and again, we mark the visited matrix for ij to be true. Also, we set up 4 boolean values v1, v2, v3 and v4 to be true. This is to recursively check all 4 directions of traversal and see if any of them return false. As you can see in the last line of this code, we do return v1 and v2 and v3 and v4. If any of these turn out to be false, then ultimately you return false in the end, which means it's not a valid sub-island. Okay, so let's look through how we're traversing. So we need to check for boundary controls, which means we check whether I minus 1 is greater than or equal to 0, j minus 1 is greater than or equal to 0, and if you're going to the right or to the bottom, then if j plus 1 is lesser than the length of the grid minus 1, and if I plus 1 is lesser than or equal to the length of the grid minus 1. After that is done, then as we've seen in the previous slide, the boolean value for val will be returned, and we can return result correctly. So what is the time and space complexity for this problem? As we are looping through the matrix, every row and every column, time complexity is om times n. And space complexity, as we're just storing one visited grid, it will be om times n as well. Thank you. Bye-bye.